How does light carry momentum? Light does not have any mass. It is a form of energy, and it is the later discussion that energy and mass are basically the same thing. But now, before Einstein, how does light carry momentum? So, before Einstein, light was actually considered as particle, made up of particle, which transfers momentum. But before Einstein, scientists also known that light have dual nature. But all the mathematical calculations for light, like how does it carry momentum, was by the particle nature point of view. But although from the particle nature view, as the fundamental particle that carries light or energy, the photon photon actually carries energy. And which type of energy? Our light, through which we see things, through which, you know, from the sun, energy is carried to earth by photons. Photons have no mass. Their mass is equals to 0. How does they carry momentum? How does light carry momentum? So the answer is actually given by considering light as particle and wave both. How both? That this is a very famous equation in physics, E equals mc square, by which we can conclude that E directly proportional to m because E is a constant. Energy and mass are the same thing. Mass can be converted into energy and energy can be converted into mass. So what is photon actually doing is it is converting all the mass into energy to make the mass 0 but having the energy. This energy is carrying momentum. So there must be a relation between energy and the momentum. Okay, and the momentum. So we are deriving the relation of energy and momentum, and that will be our answer, that how light carry momentum. First of all, welcome to the video, and this is the mathematical approach how light carries momentum. This is only a mathematical approach. This is not a theoretical approach, this is only a mathematical approach. We will discuss it about later in the next videos or sometime again. This is a very discussable topic in physics, that how does light carry momentum. Okay, now this is mc square. What is this? Is it the same thing as that we use in momentum equation, P equals mv? No, this is rest mass, which we use in classical physics, where object don't achieve the speed of light. And not in only classical physics, but in any physics, in any other study, that k p equals mv. What is this m? This m is actually rest mass. Okay, now what is rest mass? What is this new thing doing here? Take an example. When object is rest, its mass stays constant, but when it travels at the speed of light, its mass changes according to relativity. But although we know that's not true, because the mass can be converted into energy because it is constant. Mass is constant, it only can be converted into energy, and energy can be converted into mass. But now, for the sake of our understanding, our good understanding, let's say that mass changes. Okay, mass varies. Rest mass and there is something called relativistic mass, and this is the relativistic mass. Is there a relation between them? Yes, there is a relation between them, and that is m equals m naught 1 minus v square by c square under root. This is the relation, and if we what is this called? This is called gamma. The denominator is called gamma, and its value is 1 by under root 1 minus v square by c square. This gamma is called Lorentz factor, which plays an important role in relativity. Now, what we are doing, we have to derive the relation between energy and momentum. But this is the basic knowledge you should know before we derive the relation. Although it's a mathematical approach, but you should understand something. Math allows us to understand something. Okay. So now comes the derivation, how energy and momentum are related. This is our equation. Let's square it. E equals E square equals, now we are actually putting m as this, okay, no doubt, m naught square divided by 1 minus v square by c square. Now or this c square. The general formula for momentum is this, but this is not we are dealing with. Now we will deal with this, because as we know, as the particle will attain the speed of light, its mass will changes, and this is the relation that we have derived here, that m equals m naught gamma. Okay. Now we are doing something crazy. Okay, this will help us to attain the final stage. We are squaring both sides and multiplying by c square. Okay, gamma square m naught square v square and multiplying by c square. Okay, how can we write this equation? This is something. Okay, now we are subtracting these equations. Okay, then I should have to put the value, I should not have to put the value of gamma, but we have to put gamma as gamma. We have to put gamma as gamma. Okay, that is gamma square, because there is no under root, m naught square c square. Now we have to subtract these equations. Let's say this is our first equation and this is the second equation. So subtracting second from first, we have to subtract the second equation from first. That becomes e square minus p square c square. Okay, now we have to put the values. Our e square equals gamma square m naught square and c square minus gamma square m naught square v square c square. Is there something common, or we are doing a mistake? Are we doing a mistake? No, we are not doing a mistake. Gamma square m naught square. Well, there is something that we forget doing here. Is that it's basically a silly mistake that I have squared e square, but I have not squared, I have squared e square, but I forget to square the c square. This will become 4. As I was writing it before, I was thinking that I am doing something wrong, that this is c square. Think about it. Okay. Now here is actually, this is actually c square. Sorry, that was a silly mistake. that we often do in that I often do in calculations. So we can take c square common, that becomes c square minus v square. Now we are putting the value of gamma. Okay, gamma is basically equals 1 by where is our gamma, this is a gamma. If you square it, it becomes 1 by 1 minus v square by c square. So we put the value c square minus v square, c square minus v square. Now this is just a basic calculations. C square minus v square, c square minus v square under root c square. This will cancels out, and here we get m naught c 4. This will square, there will be powers will add up, and this is basically equals this. So that becomes e square minus p square c to the power 2 equals m naught square c to the power 4, and the end result is actually m naught square c to the power 4 plus p square c square. Now if we say that that the rest mass is actually 0, it's basically c square here. Okay, it's basically c square here. If we say that the rest mass of the particle is 0, that is in the case of photon. Okay, don't forget this, that the mass of photon is 0. It is defined as 0 at rest. Even though a photon is moving or it is at rest, it is massless. This is truth, that a photon is just a packet of energy, and we define that the energy carries momentum. How does it carry? Because of this equation. Let's, we have to modify this equation, or we have to just, now I'm saying that for proton, this is for photon. For photon, m naught equals 0, because photon have no mass, so this becomes 0. We get that e square equals p square c square. Okay, now that can be written as taking root both sides, we get e by c. Now what is this? This is the new formula for our momentum. See here, there is no mass, although there is a momentum, which means if there is energy, and obviously there is the speed of light, then there will be momentum, and it will be carried by photon. So this is how light carry momentum. We haven't taken the particle nature, we haven't taken the wave nature of light, but it basically balances out between both of them. So by staying neutral to both of them, we have derived this equation for our new momentum. Call it just a new momentum. I'm just not good at taking names, not good at calling things. So basically the end result is this, that P equals E by C, which means energy can transfer momentum as the photon do. Okay, so I hope you understand this, and maybe sometime later we will discuss a theoretical, this was a mathematical approach, that how does light carry momentum, and maybe in the next video we will talk about that how does light carry momentum by a theoretical approach. Okay, there will be no such calculations. Okay, and who likes calculations? All like theoretical physics. Okay, then we have to uh, make a good discussion on it. So till then, take care and be with Physics Rays.